Hello again, everybody, and welcome to the third lecture. For Chapter 3, I usually deliver this in 1.5 to 2 different lectures because it can run a little long. So I think I will cut it up and kind of go half and half into the 3 claims first, and then I'll do another lecture on the 4 validities since it runs a little long. So let's get started. I don't think I need to mention anything different separately. So in this chapter, the first 2 chapters, of course, we looked at sources of information and how to trust ones, and also reasons why we can't just trust people's authority or intuition. And this is where a lot of stuff gets blown out of proportion. So after the first 2 chapters, you guys should have been able to do the first couple assignments and be able to at least start to look at, if you didn't do it yet, the first discussion based on what you think is legitimate sources of information. Now we're going to get into the actual idea of what it is that we're doing as producers of research. So we're going to look at the 3 different claims that are made for psychology research and the 4 validities with which we sort of fit the narrative or fit the design of our research in. Not all of these validities are going to be necessary or important or even count for the 3 types of claims, but I will go over each of the claims and then the 4 validities and how they play into each of those claims. So looking at the learning objectives for Chapter 3, we are going to talk about what a variable is, and I will distinguish a variable from its levels or values. I will discriminate between manipulated and measured variables. And of course, that first assignment on cheating gave you sort of a head start on remembering what a manipulated and a measured variable is. And just in case you didn't fully get it and you just kind of followed the rules, then we can talk about it a little more here. I will describe a variable both as something conceptual, sort of the general overall. Remember, we talked about basic and applied. Conceptual variable is kind of on a basic level. What does this mean overall? And as an operational definition. And an operational definition is specifically how you, or how the researcher specifically defines this variable. For instance, if we were to talk about the word aggression, well, aggression overall obviously means the act of being aggressive, but it can be measured in different ways. I can define aggression as the way that I want to measure it as making you mad in a road rage simulator and counting the number of cuss words you use, or the number of times you stick up your favorite finger and tell me I'm number 1. I can put 2 people together and make an aggression thing, and I can see how close they get in each other's face or how many times they punch each other or try to. I can also take a measure of blood pressure. Before, at baseline, I can take your blood pressure, then I can do something that makes you angry, and I can measure your blood pressure again after you've been quote unquote aggressive. So there are many different ways to specifically operationally define how you're measuring a variable. The conceptual part is just the overall definition itself, what it means in general. I don't know why it says 1, 2, 1, 2 again. It should say 3 and 4. That's my fault. But the third one was to describe the variable as conceptual and operational. Number 4, as it should be, is to indicate how many variables in the 3 types of claims. So we have frequency claims with 1 measured variable, association claims, which you guys probably know more as correlation. Remember, it does not imply causation. And that's 2 measured variables. And finally, causal claims, which are our true experiments. And those involve 1 manipulated and 1 measured variable. And of course, that manipulated variable, as I talked about since chapter 1, has at very least two levels, a control group and an experimental group, but we'll get to that. When we talk about associations or correlations, I will talk about the types of association that we have: positive, negative, or zero. So there's three types, or as I like to say, 2.5. I will identify verbs that signal causal claims versus association claims, and then apply the three criteria that are used to evaluate a causal claim. These are called covariance, temporal precedence, and internal validity. We will identify examples in which writers' and researchers' claims are not necessarily justified by the studies they're describing, because we want to make sure to be good producers of research by being good consumers of research and understanding it. And we will appreciate that very few studies can actually achieve all four types of validity at once. And so we either don't need all four types, or sometimes we have to prioritize some validities over others. So I'll do the first half now, and then I'll come back and give you part two. What is a variable? Well, a variable is defined as something that varies or changes. You can manipulate it to change, meaning the researcher can set it to whatever levels or numbers they want, or it could be something like, in our example of the studying, it can be the outcome, which is a number that changes. However well you do on the test, that's what number you score, or however poorly you do on the test, that number can change. That's what we mean by variables, is that this variable has the option of changing, or it's something that changes. So we talk about variables versus constants. We're going to talk about manipulated and measured variables, and then looking at conceptual variable to operational definition. As you would probably guess from what I just said, a variable is a number that always, or a thing that always has the capability of changing. When we use the word constant, those are things that do not change. They remain constant, which means they either remain at one level, or most of the time it means they're eliminated, so they're not even part of the study. Let's get into that. Measured variables are the ones that are observed and recorded. A measured variable in a causal claim, which is an experiment, is what we call a dependent variable. So when we went over the cheating homework, we talked about the measured variable being the number of matrices that people claim to have solved, or that they did solve. Those are observed, those are recorded. That's your outcome a lot of times in that case. But measured variables specifically are just variables that are observed and recorded. We have measured variables in a frequency claim, at least one measured variable, whatever you're measuring. We have two measured variables in a correlation or an association claim. The measured variable in a causal claim is what we know as the dependent variable. So anything that you're measuring and recording and observing is a measured variable. An example of a measured variable: how many matrices that are solved, whether cheating or not cheating, right? Overall, don't worry about the condition of cheating or not cheating. Just how many matrices are solved, how many questions you get right on an exam, how many times a person smiles in a conversation. Whatever you're measuring and recording, whatever that number is, that's your measured variable. A manipulated variable, on the other hand, is a controlled variable, because that number doesn't change, or that variable doesn't change. It's set by the researcher. So if I'm putting you into two groups based on studying or not studying, those are manipulated by me. I make the decision. I manipulate what groups are being made. So I can have my two groups that we started with: 0 hours of studying, that doesn't change. 6 hours of studying outside of class, that doesn't change. So those are controlled or constant, right? The manipulated variable is only in a causal claim. You won't have any manipulated variables in a frequency claim. You won't have any manipulated variables in an association claim, or what we call a correlation. Only in a true experiment where we're trying to assess if one thing causes another, if A causes B. So manipulated variables are controlled. If I wanted to make 4 groups, I could say 0 hours one group, 2 hours of studying second group, 4 hours of studying for the third group, 6 hours of studying for the fourth group. I can manipulate and control how many groups there are and what the groups consist of. So a measured variable is your outcome, or observed and recorded. That's usually the cheat sheet way of remembering this, is whatever number you're getting from this study, whatever number is going into your statistical analysis. Are we measuring the number you got right on an exam? Are we measuring the number of times somebody cheated? Are we measuring the number of matrices that they solved? Those are measured variables. Manipulated variables are the ones that the researcher gets to set. Studying, not studying, 0 hours or 6 hours versus 0 hours. In a drug trial, right, it's placebo versus 50 milligrams of a medication. So now it gets a little more complicated, but hopefully not too much. There's certain variables that can only be measured and not manipulated. Scores, like exam scores, can be measured but not manipulated. Things like that. And of course, I would ask you guys if you had examples of this as well. So some variables only can be measured and can never be manipulated. One of the things that you can never manipulate is something that people are born with. So if you have blue eyes, right? A number of people with blue eyes, or things like, actually we can manipulate blue eyes versus another one, but so that's not the best example. But some variables, as I said, can only be measured. Other variables can either be manipulated or measured. And again, this is where I ask you guys if you have any examples. But variables that can be manipulated or measured, you can manipulate a group into lower weight and higher weight. So you can also measure somebody's weight. In this case, those over 165 pounds could be in one group, and those under 165 pounds can be in another. And of course, weight itself can just be a measured variable because literally you're measuring it. Height is another good one that can be measured or manipulated, right? Because you can put people into groups based on their height, based on their weight, based on their age. So these are the variables that can be either manipulated or measured. If you're over 21, you're going to be in this group of adults, 21 plus. If you're under 21, you're going to be in the other group. That is a way to manipulate age. Or we can just simply measure. What is your age? You're 25? Okay, that's a measured variable. This person is 25 and they got this score. So variables can be either manipulated or measured, and there are some variables that can only be measured and not manipulated. Hopefully you're still following along. So let's look at an example and see if you can understand why this variable is either measured or manipulated given the context. Now, this is your first exposure to it, so if you're not quite getting it, you can go back over this. But hopefully it should be relatively easy to see. Again, measured is observed and recorded. Manipulated means that the researcher is responsible for putting people into these groups. So the first one, the conceptual variable. The other thing that we talk about with conceptual and operational definitions, as I pointed out on the objectives, is that the conceptual variable is the overall accepted definition. Conceptually, we know what this is and how it's defined. The operational definition is how the researcher, myself or you guys, whoever, decides to specifically define it the way they're going to measure it. So, in this case, the first variable on the left, as you can see here, is called vocal fry. And that is a sort of tone in your voice when you're talking. A vocal fry is kind of a low vibration at the end of a sentence, kind of like that. So looking at vocal fry, that's your conceptual variable. Okay. So one possibility of an operational definition, researchers audio recorded women talking and coded the degree to which the speaker uses a low guttural vibration, aka vocal fry, at the end of a sentence. They could see how many times people used it at all. Specifically here, it was the end of a sentence. So, are there levels for this variable? We have 3 levels. We have low vocal fry, low amounts, medium amounts of vocal fry, and high amounts of vocal fry as determined by people coding. So somebody recorded a conversation and then they listened to it and they recorded and wrote down every time a person used vocal fry. In this context, they were broke it up into 3 levels, but that doesn't mean that they knew what the 3 levels would be. So, in this case, it is a measured variable because they are just simply counting the number of times that's used in a sentence. This is measured because they're observing and recording it as they listen. I hope that makes sense. Here is whiff of rosemary. Just, oh, that smells like rosemary. We know that rosemary is used as a cooking tool. It's a plant. It can be used to season food. It could be used as an essential oil. So in this case, specifically, researchers exposed participants to either rosemary essential oil or a neutral fragrance. There were 2 levels: presentation of rosemary or no rosemary, meaning a neutral fragrance that had nothing to do with rosemary. So in this case, if researchers were exposing the participants, this is a controlled variable because the participants either, right, they're not measuring the number of times that they sniffed rosemary or that they guessed correctly. They said researchers exposed participants to rosemary essential oil compared to a neutral fragrance. So in this case, it's a manipulated variable because either they were exposed to, in the group that was exposed to rosemary, or they were not. This is not saying what they measured. So this is a manipulated variable. What about gender? Gender asked people to circle either male or female on a questionnaire form. Well, we have 2 levels. You're either male or you're female. People were not separated into groups of male or female. It's an anonymous questionnaire or survey, and they're asked to write down, are you male or female? At the end of the study, when they were doing the statistics, you would imagine that they wrote down the number of people that answered male and the number of people that answered female. In this case, you guessed it, it is a measured variable. Finally, we want to look at something like quality of sleep. And if you're looking at a word like quality, it should be a dead giveaway that you are observing and recording something. So in a sleep clinic, sometimes people go and do sleep studies based on nightmares or snoring or things like that. Maybe they just have bad amounts of sleep and they want to try to increase their quality of sleep. So in a sleep clinic, researchers used sleep monitors and timed the number of minutes participants engaged in deep sleep, or what we call stage 4 sleep. So the variable could have multiple possible levels because you are measuring it in minutes. You're counting the number of minutes that a person sleeps in this stage of sleep. In this case, obviously, this is a measured variable because they are observing and recording the total number of sleep minutes in this stage of sleep. So it is a measured variable. Hopefully, you understand the difference between the 2. So, if we wanted to use our own example from the book and operationalize something, we know the conceptual variable, we can define the conceptual variable, and then we can look at the different ways to specifically operationalize it. So, someone wants to do a study because it's dangerous and because they really want to know more about how the brain is distracted or something like that when somebody is texting while driving. So, Up here is our conceptual variable and our cloud over here. The idea is texting while driving. Well, the conceptual definition is pretty easy on this one. Actually texting while you're driving. One of the things that we may not know is how you define texting specifically, because there can be a little bit of variation. What I mean by that is that texting could be literally putting your head down off the road and actually putting in the words and letters with your fingers while you're texting. But could texting while driving also mean using talk to text and hitting the little microphone button in the corner? I have an iPhone, so that's how it works for me. Hit the microphone button in the corner, which either goes straight to the phone or goes through the car stereo, and you can talk while you're texting. That's really up to you. Either way, I think the conceptual overall would be either of those, right? Either using your thumbs or fingers to text while you're driving, or talk to text while you're driving, because either way, you're still texting while driving. Hopefully you're still with me. So that's the overall definition. If somebody really wanted to be operational about it, even before we get down here on how you're going to measure it, you can be specific. You can say it could be talking or actually the act of texting, as long as you're while driving. And driving could mean while the car's in motion. It could also mean while the car's at a red light, right? You can decide what that is. And it could be any of those for the conceptual definition. So overall, it's just the frequency or how often it's done while driving. Doesn't really matter conceptually if it's talking or if it's actually putting your fingers to the phone, or if you're at a red light, or if you're on the freeway, or if you're in motion. Those parameters can be set. The overall definition is just any of that. So there are different ways to measure it. As I used the example of aggression, I said that people could define it as a change in blood pressure. They can use it define it as the number of cuss words used, or the number of times they stick up that finger at you. They could use it as how often they are in somebody's personal space, or how many times they put their hands on or try to hit another person. All of these could be different operational definitions of aggression. So for this one, we can ask in a self-report, and we can ask people, how often do you text and drive? We can either give them an open-ended answer, which is sort of what we call qualitative and not quantitative. We want to stick to stuff that we can directly measure, especially in this class. So let's say quantitative. We'll give them options to answer from. In this case, almost always, frequently, occasionally, or never. Now, those aren't really specifically defined. So I guess it's up to the participant to sort of get it. I mean, you could also go with something like, 0 times, 1 to 4 times a week, 5 to 10 times a week, and then more than 10 times a week, or something like that. So that is one specific operational definition based on their own self-report. One of the things that we'll talk about during this class is that a lot of times self-report is necessary for the way that we gather data, especially in a time where we can't be in person with people. But it's not always the preferred way to do things. It is one of the easiest ways to gather a lot of data if you need it. But self-report is probably especially unreliable depending on what the subject is. So what that means is people have the tendency to lie if they want to look good or bad. In the next chapter, in chapter 5, we'll talk about things that you can do on surveys and questionnaires that try to get people to be encouraged to tell the truth. Second one is called direct observation. You can literally have a person standing outside or sitting outside, and as cars pass by, we can look at, in this one, it's the number of times a person does it, maybe in a week. And of course, you can define that specifically in a month, in a day, however you want to define it. Direct observation could be a little different. It could be a person sitting on a corner with a clipboard and a pencil, and looking at people that drive by. And for every car that drives by, he can say, I sat there for 2 hours and I saw 24 vehicles where people were texting as they drove by. So direct observation is always good. It doesn't mean that somebody has to be there in person. You can use a camera and film them. It gets a little tricky with permission and stuff like that, but it can be done. And that is another way, direct observation, having somebody count the number of people that they see texting and driving. The third one is maybe just have a friend observe it. So you can have somebody that's in your carpool, let's say for work, and they say in the carpool, how many times do the people, and if it's in a carpool, a lot of times it's not the same person driving every day. Or maybe it is. Maybe you're just carpooling with someone from work and you don't have a car, so they offer to drive you every day. In that case, that person can report and write down or take note of every time the person does it for a week of work, right? Monday through Friday or whatever it is, if you've got the 9 to 5. So 3 different operational variables that are very specific and different from one another. Self-report asks you to report on yourself. Direct observation is having somebody actually observe the number of cars, or your friend in a carpool for that week observing the number of times that a person texts to the best of their ability. So from one conceptual variable, we can operationalize it in 3 different ways. There may be more ways to operationalize it, but I'm not going to go over that. If you can think of more, great. Now, let's look at the 3 claims. Again, we have frequency claims, which, as I pointed out, are using one outcome or one measured variable. So you're only going to get one number out of these. And a lot of times, surveys, polls, things like that, you only get one number. So it could be something like, as you see here, 1 in 25 US teens attempt suicide a year or in their lifetime. 79% of people think that regifting is acceptable. More than 2/3 of college women use this vocal fry sound that we kind of went over. So that is a frequency claim. If you ever hear surveys, polls, poll questions on Twitter or online or in a TV show, how many people think that contestant A is going to cheat on contestant B? And we get, people that go online and they vote, and we see that 72% of people think that, this person is going to cheat on this person. That is what we call a frequency claim. 4 out of 5 doctors recommend Colgate. 42.7% of statistics are made up on the spot. Did you get that one? Did you catch it? Go back and listen if you didn't. Again, I make bad jokes. I don't apologize for them. The second this type of claim, frequency claim, is one measured variable, one number, 1 in 25, 79%, over 2/3, 42.7% of statistics, one number, one measured variable. Association claims, or types of associations, are also what we refer to as correlations. Remember, in correlations, as I've said since Chapter 1, we're not looking for cause. We're not looking to see if A causes B or anything like that. If you have 2 variables, you're looking to see if A and B have a relationship with one another. So we're not looking to see if there's cause. We're just looking to see the degree to which they're related. And if you have 2 factors or 2 variables, they both need to be measured. So an association claim, aka a correlation, has 2 measured variables. So if you're keeping score at home, a frequency claim, 1 measured variable, association claims, 2 measured variables, because you measure one thing, you measure another thing, and then you put those numbers together and see how much they may be related to one another. Association claims could be something like mixed weight couples argue more. Smart jocks, fit kids do better at math and reading. So there must be a correlation between the weight of the couples and how much they argue. You would measure the weight. That's one measured variable. You would measure the frequency of their arguing, however you want to do it, per day, per month, per week. And you have two measures. Smart jocks, fit kids. So you have kids that are fit and healthy or do a lot of exercising, and maybe ones that, right, you just measure how fit they are or how healthy they are, and then you look at their math and reading scores. Bedroom TVs may boost kids' risk of fat and disease. So you look at how many bedroom TVs that people own, and you look at their percentage of ones that are overweight or have some sort of diagnosis, maybe, due to that, like diabetes or things like that. So those association claims, again, are just looking at a relationship between two variables. Here is weight and arguments. Here is health and academic scores. Here is number of TVs and the risk of fat or disease. So association claims are two measured variables. The last one, and this is the one we're going to concentrate on in the second half of class, because this is what we're going to base our actual experiment and manuscript on, is a causal claim. Causal claims also have two variables, but not like an association claim. In an association claim, you have two measured variables. They're called predictor and criterion variables, and we'll go over this very specifically in Module 2 in Chapter 8. Causal claims are the ones that actually are called causal claims because they are trying to make a claim that A causes B. So when I came up with that experiment example of studying causes you to do better on an exam, I'm saying it actually causes you to. So A, studying versus not studying will cause you to get a higher score on the exam, and not studying should cause you to get a lower score, all things being equal. So causal claims could be something like music lessons enhance your IQ. So those, what they're claiming is those that take music after school or private lessons will have a higher IQ than those that do not take music lessons. This is a causal claim. Texting blamed for rising teen pedestrian injuries. So if you text while you're walking or driving or things like that, more injuries. This says pedestrian, so maybe it's while you're walking. Study, creepy people literally give us the chills. So you would have two groups, creepy people versus not creepy people, however you operationally define it. And you measure the amount of chills you get, or maybe on a survey, on a scale of 1 to 10, how creepy was this person? Or how many chills did you get? Shape of glass may influence how fast you drink. We have one glass in one shape, another group has a glass in another shape, and we measure for everybody how fast they finish drinking that glass of whatever, water. So a causal claim has two variables, one measured variable, which is your outcome, your DV or dependent variable, and one manipulated variable, which is called your independent variable. Why is it called a dependent variable? Because your score that's measured is dependent on which group you're in. If I go back to the studying causes you to do better on an exam, the dependent variable is your exam score. Why is it a dependent variable? Because, as we predict, the score you get at the end depends on whether or not you studied. So it depends on what group you're in. What we predict and hope to find is that those that are in the control group, 0 hours of studying, are going to get a lower score on the exam. But if you are in the group that studies 6 hours a week, you are going to get, that is dependent on if you get a higher score overall, averaged, right, for the group. So the manipulated variable is the independent variable, and that is what groups the researcher puts you in, 0 hours versus 6 hours. The dependent variable is the measured variable or the outcome variable, and again, it's that thing that you're measuring. So in this case, texting is blamed for rising teen pedestrian injuries. So we can have two groups, one that texts while walking, one that does not text, and our outcome is the number of injuries that are sustained. Here we have creepy people give us the chills. So you have people that are defined as creepy versus people that are defined as not creepy. Maybe it's the way they look, the way they sound, all of the above. And they literally give us the chills. So how maybe it could be a scale of 1 to 10 on chills, or it could be counting the number of times somebody shivers, or something like that, some sort of response. Shape of glass may influence how you drink. Maybe you have one straight cylindrical glass for water, and another one has like a curved glass or some sort of different than just a straight cylinder glass. And you put, 12 ounces of water in each, and you literally time how fast they drink. In this case, the shape of the glass, regular glass versus a curvy or different glass, would be the manipulated variable. How fast you drink, somebody has a stopwatch, they time you how fast you drink, and that's the measured variable. It's dependent on what the shape of the glass is that you're given. So hopefully you can understand those claims. So again, to review, frequency claims describe a particular rate, a degree, a ratio of one single variable. So frequency claims involve only one measured variable. 8 out of 10 people think that sports are awesome. 4 out of 5 dentists recommend Colgate, as I said before. 50% of people are sure about what they want to do in life. That's probably not true at all, but that would be an example of a frequency claim, and they're one measured variable, which means one number that you're getting. A lot of times it's a poll or off a questionnaire, something like that. Association claims argue that one level of a variable is likely to be associated with a particular level of another variable. So association claims involve at least two measured variables. Those variables that are associated are correlated or correlated. So that's when we talk about a correlation. We're not looking to see if one causes the other. We're just looking to see how well they're related to one another. One of my favorite characters from The Simpsons, and yes, I'll show my age because I've watched The Simpsons since the very first season, and I think I've seen almost every episode, if not every episode. The earlier ones, to me, of course, are more memorable than the later ones, but that's neither here nor there. There is a fun character, a little side character that shows up every once in a while called Crazy Cat Lady. And she sort of speaks in tongues, nothing coherent, and she has a lot of cats. And in fact, sometimes, I don't remember if it was a Halloween episode or if it was just her being weird, she even hurled cats at people because she's got so many to spare anyway. So you guys may have heard the term Crazy Cat Lady. I don't know if it originated on The Simpsons, but one of the claims that we could make as an association claim is based on the term Crazy Cat Lady, maybe it's the more number of cats that you own, the less sane you are or the more crazy you are. So how do we figure that out? We can use two measured variables. We can measure the number of cats that you own, and we can measure your mental health on some sort of sanity or insanity scale. Let's just say on a scale of 0 being completely sane to like 20 being batshit crazy. Pardon my French. So we measure somebody's number of cats they own. They own 3 cats and they're at a level 4 on this scale. Somebody else owns 0 cats and they're at a 0 on the scale of sanity. Somebody owns 10 cats and maybe they're at 15 out of 20 on this scale. So we look at the numbers together of how many cats are owned, and we look at the numbers of how crazy or not crazy they are, and we make an association. Two measured variables. One is the number of cats. That's a measured variable. And the other one is the sanity of the person. That's an association claim. Two measured variables, number of cats and how crazy they are. We can look at things like height and weight in children. As children grow, their bones get bigger, their body mass gets bigger, they need more skin. So they tend to get bigger and gain weight. This is not the same as when they become adults because you stop growing, and you may gain or lose weight, but there's not much of a relationship after 18 to 21. But growing up, you may see a direct relationship. The more inches that a child grows, the more weight they usually put on. That is another correlation or association. So we have three different types of association. I would actually say 2.5, really, because one of them is zero association, which just means they don't really have much to do with one another. So looking at this chart, on the x-axis down here, we have a measure of shyness. So maybe on a scale of 0 to 15, how shy a person is based on a questionnaire. And their ability to read facial expressions, how well they are able to read another person's facial expression. Maybe those that have more shyness can read more facial expressions, and those that are less shy are not able to because they're more verbally better able to communicate. But if you have a positive association, it will give you a number. By the way, the correlation, if you don't remember from Psych 1, is a number from -1 to 1. And that number that you're given is called an R value, or an association value. From 0 to 1 is a positive association. And what a positive association looks like on a scatter plot, this is a scatter plot where a bunch of points are plotted. So, for instance, this person over here looks like they got about a 6 or 7 on shyness, and their ability to read facial expressions is down here at 1. This person up here got a 15 on the shyness scale, very shy. Their ability to read facial expressions really high. That's a 7. This person's kind of in the middle, got about a 9 on the shyness scale, and about a 3 in ability to read people's facial expression. So all of these plots are given, and a lot of times for the number, they take a line of best fit on this graph. So you can see that the way the numbers or the plots are spread, that you see this trend of going upward like an upslope. That shows a positive association. What a positive association means is that as one variable goes up, the other variable also goes up. So the more shy you are, according to this sample, the better you are able to read facial expressions. Or at least that there's a positive relationship between the two, right? It could be the same. A positive association doesn't just mean as one goes up, the other goes up. It could be as one goes down, the other goes down. You're still going to see this trend in the same way of an upward slope. So what do I mean by that? It just means that the two variables are going in the same direction. So shyness and ability to read facial expressions are both going up. The number of cats a person owns and their degree of insanity, right, or their score on the insanity chart goes up. That's a positive association. But it could be two things that go down together. So somebody that's trying to lose weight is going to decrease their calorie intake. And the hope is, at least with the decreased calorie intake, that your overall weight, which is measured, is also going to decrease. So they look at people's number of calories per day, and maybe the normal one is around 2,000 calories per day. So this person is showing 1,200 calories per day on their diet, and their weight goes from 200 down to 180. They lose 20 pounds. So as they cut their calories, they're also losing weight. That is also a positive association because it is going in the same direction. So as long as two things are both increasing like this, more shyness is associated with a higher ability to read facial expressions. It could also be two things going down at the same time. Caloric intake goes down, overall weight in number goes down. Those are both examples of positive associations. As long as the variables are either both increasing or both decreasing, this is a positive value, positive association, positive correlation. That would be a number on the positive side from 0 to 1. A 1 would be a perfectly positive correlation, meaning for every 500 calories you cut out of your diet, you lose 1 pound a week or something like that. For every inch a child grows, they gain 1 pound. You're never going to get a perfect correlation like that in real life, the way that goes, but you may get something close to that. Now, what we can tell from an association that's closer to 1, if it's anywhere from 0.8, 0.9 to a 1, then there's a much better chance, and this is where we're going to be going with this homework this week, there's a much better chance then that they would show some sort of cause. So we can't ever say that A is going to cause B from a correlation or an association, but if they're close enough, we may be able to design an experiment to test it. On the opposite hand, we have a negative association. And as you can see here, instead of an upward slope, if you're looking at this, the flow of this scatter plot, you can see the trend, you can see that the plots are going down in a negative slope. In this case, we have a negative association. So it's basically the opposite of a positive association. In this case, what you're seeing is as one variable goes up, the number of multitasking things that you do, this is frequency of multitasking, so doing one thing at a time, 2 things at a time, 3, 4, 5 things at a time, this is your skill at overall multitasking. Now, I realize that the post-millennial generation and the millennial generation are the ones that are kings and queens of multitasking because we have a lot more things going on at once. You have the internet in seconds that you can accomplish. A lot of you guys and girls are a little bit more adept at doing multiple things at once than back in the other generations before you. But that doesn't mean that you're necessarily going to be good at it, even though you have more experience with it, because a distracted brain is not a functional brain. So the more things you're doing at once, the less you're good at each of those things. And that makes sense. We can show it on this. So doing one thing, there's one person that's not very good at it, but 3 people that are pretty darn good at it. As we go through, 2 things at a time, a little lower. 3 things at a time, there's one person that's really good at it, and most of the people are not. And as you go to 4 things at once, 4 people, pretty low scoring. 5 things at once, 2 people that are really, really in the low scoring at skill of multitasking. So the more you multitask, the less good you are at any of those things. Overall, there is a negative association. This would be somewhere between 0 and -1. A perfectly negative association would say that for every one thing that goes up, another unit goes down. So the definition of a negative association is that as one goes up, the other is going down. So this is going up, the number of multitasking things, and how good you are at each thing is going down as you increase the amount of multitasking. So we can go back to weight loss, and we can say the number of healthy meals you have, the more your weight goes down. That would be a negative correlation based on weight. One example that I particularly like, because I am always hot and never, ever, ever cold, so some of my friends suggested I should move to Minnesota, but that ain't ever happening. I'm an LA guy, tried and true. So it doesn't get Arizona hot here, but it gets pretty warm, especially this summer it was. All right, off topic. When it gets hot, one of the things that people can do is take off articles of clothing, right? I opt for flip-flops so that my feet can breathe. I don't need socks and shoes smothering them. Not really smothering, but covering them. So a negative association could be for every, when the temperature goes up as it gets hotter, you remove more clothing until you're in a swimsuit maybe and nothing else. As it gets colder and the temperature goes down, you're putting on more clothing. So if you do go to Minnesota in the winter, right, as the temperature goes down, you're putting on jackets, scarves, gloves, right? More things. So if we were to describe a perfect negative association, for every degree the temperature went up, you would remove one piece of clothing. So if it went from 95 to 96 degrees, you remove one shoe. If it went to 97 degrees, you remove two shoes. 98, you remove a sock. 99, you remove another sock. So every degree it goes up, you lose one article of clothing. Or for every degree it goes down, you put on an article of clothing. For every time it goes below 65, if it goes to 64, you put on one glove. If it goes to 63, you put on another glove. It goes to 62, you put on one sock, right? Something like that. So that would be a perfect negative association. And finally, we have, this is why I say it's 2.5, not really 3, because if you have a true zero, what this usually means is that there is no relationship between A and B. So in this case, there's a lot of people that claim the amount of screen time that a person has, especially if it's your child, for children, for school, the amount of screen time that they have looking at phones and computers and tablets, the less physical activity they have. Now, I happen to know that although this is a claim that many people make, it's just not necessarily true, especially if especially in today's world, because obviously we have to be at computers and laptops, and that's how schooling is going. But just think of it, before any pandemic or anything like that. And, there were a lot of websites on development and things like that say, don't let your kids watch tablets. People from Apple never let their kids have iPads. There is way, way, way more educational games anyway. And when my son spends time looking at a screen, it's usually playing something educational, and it doesn't make him want to run around less or play sports less or go bike riding or skateboarding less. So here we see level of physical activity is all over the map. The amount of screen time is all over the map. Sure, we may have some kids that spend 2 hours of screen time and don't have much activity. Here's 2 hours of screen time and middle to a lot of activity. Down here, 16 hours of screen time, and this looks like a really decent amount of physical activity, right? Half of their time is physical activity, and a lot of it, they're just not sleeping, apparently, this kid. Here in the middle, we see somebody with 10 hours of screen time and about a moderate amount of physical activity. So here, if you don't have a line of best fit that goes upward sloping or downward sloping, what you may find is that your line of best fit is just a straight, flat, horizontal line. And what that shows is that there is no association between this. So people can parent however they want, and I'm not going to take that away because it's your child and your thing as long as you're not endangering them. But in this house, we have a nice balance between screen time, video game time, TV time, and going outside and playing. And my son does a lot of both because sitting still is usually not an option, even when he's eating a meal. So zero association means that there is no association between the two variables, like amount of screen time and level of physical activity. You can come up with your own examples of things that you can measure them, but they don't really go together. So we can make predictions, as I said, based on associations. Some association claims are useful because they can help us make predictions. So again, the closer you get to +1 or -1, remember that there is that in a association, in a correlation, there is no difference between positive or negative numbers other than the direction of the association. So what that means is a positive 0.8 correlation shows that two things are increasing or decreasing at the same way. A negative 0.8 correlation is saying that one goes up and the other goes down. But which is better? Positive 0.8 or negative 0.8? That's a trick question. They are exactly the same strength. Positive just means two are going in the same direction. They're both going up, they're both going down. Negative just means one goes up, one goes down, or one goes down, one goes up. So the number, whether it's positive or negative, is going to be the same if it's the same number. 0.8 positive, 0.8 negative. 0.2 positive, 0.2 negative. So don't think just because it's negative it means bad or it's worse than positive. It's just not true. So these association claims, again, correlation does not imply causation, but they help us to make predictions. They can say if you're between 0.8 and 1 or negative 0.8 and negative 1, the stronger the association between two variables, the more accurate the prediction is. The bigger relationship they have, the more they have in common, and the more likely it is that one can cause the other. So although you can't make that claim in an association, in a correlation, you can it makes it more likely that they do have something in common, that one can cause the other, and then you can make a causal claim based on this. So both positive and negative associations can help us make predictions if they're high enough. Zero associations cannot. That may mean they have almost nothing or nothing in common. One of the links that I gave you for, after chapter 1 is a website called Spurious Correlations, which is kind of funny, and I hope you get a kick out of it. But it's showing two things that on paper or in a graph look like they're very closely related, but they're actually not. So there can be some things that look like they're related, but they should have absolutely nothing to do with one another. Zero associations, of course, just have nothing to do with one another. So go ahead and click on that Spurious Correlations when this is over, and then we'll go over this week's assignment, or next week's assignment, because the end of this week we're actually doing we're actually doing our first experiment. So we'll get to that. So looking at causal claims, actually, I think this is a good time to stop because it's probably been the better part of an hour. I don't really have a timer. For part 2 of this lecture, I'm going to start with causal claims, and then we'll get into the 4 validities that they go for. The reason for this is that you probably want to break, and also causal claims are the only of the 3 that have what we call internal validity. The other 2, association claims and frequency claims, that does not apply. So I'm going to stop here, and I will bid you adieu for now, and we will pick up where we left off when you're ready. So, as always, I will talk to you soon.